In this video, we're going to talk about nonlinear systems and how to solve them. Before you even attempt this lesson, make sure you're comfortable with solving a linear system by substitution, factoring quadratics, and the quadratic formula. If you're not comfortable with all those, then this is going to be kind of too much for you, so go back and look at those things first. Make sure you're comfortable with them before you move on. So nonlinear system. So every system we solved so far has two linear equations. However, there's no reason that they have to be lines. We could have parabolas, we could have some other things we haven't really talked about in terms of graphing, really like circles and things. But anytime one of the equations in your system is not just a straight line, then it's a nonlinear system, right? Nonlinear just means it's not a line. So as a strategy for solving these, really there's nothing new to learn. You're just going to solve it using the substitution method we already learned to solve a system. The only difference is going to be the kind of equation you're solving at the end is going to be more complex. It's not going to be linear anymore. We have to remember most of the time it's going to be quadratic because that's what we just reviewed. So here's our example. Y equals x minus 3, x squared plus y squared equals 9. If you were to graph this, you'd actually see it's a circle. So we have this kind of line and circle crossing each other. This is a line, this is a circle. And you can see we might get these two different answers for where they intersect. Just like when we saw graphing a system by solving a system by graphing, intersections are important. And this one we don't have to do much work. We already have y equals. We know there's a relationship between y and x, and we can take that and we can plug it into the other equation. So this is going to be x squared. Instead of y squared, it's going to be x minus 3. That's what y is equal to. Squared equals 9. And here's where you have to be really careful with notation and other things we've learned, kind of the basics of algebra. X minus 3 squared, let me just kind of write it over here. That's the same thing as x minus 3 times x minus 3, right? Squaring something just means you multiply it by itself. When I multiply two things that look like this together, I have to FOIL. So my next line is going to be x times x is x squared. Outer x times minus 3 is minus 3x. Inner, I also get minus 3x. Last, minus 3 is plus 9. The most common mistake is saying that x minus 3 squared is x squared minus 9, and that's it. You can't just put this squared on these two things. You have to FOIL it out. So that's the most common mistake. Just make sure you're careful with that. Now you can combine some like terms. 2x squared minus 6x plus 9 equals 9. So now you can see the difference between our solving linear systems versus nonlinear systems. Here we have a quadratic equation to solve. So how do I solve a quadratic equation? The first thing I do is get 0 on one side, in this case subtracting 9 from both sides. From here you have a couple options. You could do the quadratic formula, but in this case it's a little bit simpler to just factor. If I just factor out the greatest common factor, and then if I factor and it's equal to 0, I can break this up into two separate equations. And x equals 3 and 0. And here's the other way that a nonlinear system is different than a linear system. When I got a linear system, I would just get 0, plug it in to get y. But in this case, I get two different answers. So I got to plug both these answers in. So first, let's do the 0. Y would be 0 minus 3. I'm plugging in for that x, which is negative 3. The other one is now y is 3. I get 0. So I get two different answers. Let's see, I'll write them in green. One answer is if x is 0, y has to be negative 3. So that's one answer to the system. The other answer is if x is 3, y has to be 0. So both those points will satisfy both equations. They're both on the line, and they're both on this circle. So the really only major difference, I say two. There's two major differences. One, when you go through the process after your substitution, you're going to have a quadratic equation to solve instead of a linear equation. If you're comfortable with factoring in the quadratic formula, that's not really any different. The other difference is you might get multiple answers for one variable. So just make sure you plug both those in to get your pairs that go along with them. Those are the two big differences. You'll be solving quadratics at some point, and you might get more than one answer. I'll just do one more. Again, there's nothing really too crazy. If you're comfortable with all the stuff we've done before this lesson, it's just putting it all together. In this case, y is equal to x. So it really gives you a lot of options. Because this is y equals, I'll take this and plug it in down there. Very similar to the last problem. Now we have x squared plus x squared equals 4. Combine that, 2x squared equals 4. Here's one thing we didn't. Let's just solve it the way we've been talking about. All right, subtract 4 from both sides. I think I'm going to solve this the way we didn't actually talk about in our kind of review of quadratics, is that I can divide both sides by 2. And if I get x squared all by itself, then I can just use square roots to solve. And the only reason I did that is because it just saves so much time over doing the quadratic formula. All right, so if there's x squared all by itself, I can solve this. And I know y is equal to x, so these are also the y values. Okay. So my answers are if x is the square root of 2, y is the square root of 2. If x is the negative square root of 2, y is the negative square root of 2. All right. Not the most difficult problem in the world, but again, you're just using your strategy of plugging the y in, squaring it, and moving on. So here's one for you to try on your own. I actually gave you guys a slightly harder one than I did on my own. Remember, we're doing substitution, so you have to solve one equation for one variable first, and then solve the other. All right, but go ahead and try this one. If you can do this one, then you're in a great place, but I'll show you the answer in 3, 2, 1. All right, you can see the two answers down here, but let's kind of follow my crazy writing. So the first thing I'm looking for, I'm doing substitution, I have to solve one of the equations for one of the variables. I'm always going to kind of avoid the nonlinear equation at the start. So I'm looking at this bottom equation, and the easier variable to solve for is going to be y. So I'm going to take this bottom equation and get the y by itself. All right, that's always our first step for substitution. And I have no choice. I have to plug that into the other equation for y. All right, so that gives me this equation. Get my little highlighter out. Right there. All right, now this equation, I can see it's just a quadratic with x, so I get everything to one side and 0 on the other side. Here's one step you might not recognize that makes the problem a little bit easier. All these numbers are even, so I just divided everything by -2 just to make the numbers smaller. All right, it's always something you can do. If you notice, all the numbers are divisible by the same thing. Now I have this 1 in front of x squared, which means I can do my shortcut factoring method and get my two answers for x. And then when x is 2, I put that into my equation for y, and I get y has to be 3. When x is 1, I put that in my equation for y, and I get x for y has to be -3. So I get these two answers. And a quick summary, when you look at a nonlinear system, if you're ever looking at a system and you see those squareds, you solve it using substitution. There's examples where you can do it other ways, but the ones I'm going to give you, you're going to use substitution. All right, make sure you check all of your answers at the end, make sure they actually work in the problems. And don't forget the FOIL. We saw that problem that had something like x minus 3 squared. Make sure when you get problems like this with a thing being squared, don't forget to FOIL.